Let's discuss question number 2 from test sets. This is from machine design. So yield strength of steel shaft is twice its hindrance limit. So sigma y is twice its hindrance limit. Which of the following torque fluctuations represent the most critical situation according to the Soderberg criteria? Well, Soderberg criteria. Let's recall what is Soderberg criteria. It says that if you plot mean stresses on the x-axis and on the y-axis if you plot the variable stresses, the limits being the yield strength and the endurance limit, then this is if any stress that point that falls between or below or to the left of this line, which is drawn between the yield point and the endurance point, somewhere here it is safe, somewhere outside it is failed. So the equation of this line would be mean by y plus variable by endurance is equal to 1. But if I need to provide some factor of safety, then this value will be sigma y by FOS comma 0. I'm providing equal factor of safety, so sigma e by FOS. So if I use this, so that sigma y by FOS, there will be FOS here, there will be FOS here, and that will become 1 by FOS. So the final equation, if I consider some factor of safety, will be this 1 by FOS, and what is given is sigma y is 2e, so sigma m by 2 sigma e plus sigma v sigma e is 1 by FOS. So I can just take sigma e there, so sigma e by FOS. Okay, so what I'll do is I'll compute this and then see which of these torque fluctuations gives me more factor of safety, because the one which gives more factor of safety will be good and the one which gives less is most critical. Okay, so first case is minus t to t, so the mean load, obviously the mean load, okay, so the mean torque fluctuation sigma mean, okay, will have, it's minus t to t, so the mean is 0 and the variable is t. I mean variable will have t component, so I mean equivalently I have to substitute, but I'm just substituting in terms of load only. So mean is 0, this is, so first case it is t sigma e by FOS, right? Yeah, so this value will be just t. So second case it is 0, okay, so second case is minus t by 2 to t, so the mean load will be adding these two by 2, so minus t by 2 plus t by 2, which will be t by 4, and variable will be subtracting, so t minus of minus t by 2, so it is 3 t by 4, 3t by 4, yeah. So this is variable. So if I just add that, if I just recall this equation, sigma mean by 2 will be t by 8 plus 3t by 4. This is sigma e by FOS. So this value will be, if I just multiply with 8, so this will be 7t by 8 sigma e by FOS. Okay, I mean there will be some constant here because we just load how, because it's just the load times something will be your variable. I mean you have to use that 16t by pi d cube, that is the formula, right? So I'm just using, this will be the formula for the shear stress, and here we need to just use our shear stress instead of, so all that scaling, so everything, all those scaling will be constant for each of the cases, so you need not worry, you can just write in terms of load. So other case is 0 to t, so in this case the mean is t by 2 and the variable is, remember this, I'm writing sigma but actually it has to be written as shear stress, so the, and variable is t by 2. So if I substitute in this equation, it is t by 4 plus t by 2 is sigma e by FOS, so this will be 3t by 4 sigma e by FOS. Okay, and the last case which is t by 2 to t, okay, the mean will be t plus t by 2 by 2, so that is 3t by 4, and variable is t minus t by 2 by 2, that is t by 4. So if I use this equation, it is 3t by 8 plus t by 4. So that is, okay, so this comes out to be 5 t by 8. So here if you consider these four equations, I mean this as well as this equation, we'll get to know that FOS is less in the case 1. FOS is less in case 1. Okay, when compared to this, because here it is 8 by 7 times t, here 4 by 3 times t, and here 8 by 5 times t. So case 1 it's only t, so it is less than case 1. Case 1 is most critical. The answer for 2 is A. That is more critical. Thank you.